So a quick review of the different states of matter, solids, liquids, and gases. In a gas, the particles are very far apart, and this gives gases a low density. So this is in grams per cubic centimeter, 0.00059 is kind of an average density. In a liquid, the molecules or atoms are touchingly close. So they're much closer than they were. Now the density is going to be much higher. So here we're looking at water in the gas state, water in the liquid state, and water in the solid state. In the solid state, the molecules are also touchingly close, but now they can't move relative to each other. They form ice crystals, and they form a regular repeating pattern in space. They're still moving, but they're just kind of wiggling back and forth. Big difference between solids and liquids is freedom of movement of the particles. So in a liquid, the particles have enough thermal energy. Remember, thermal energy is related to kinetic energy. So it's how fast they're wiggling or traveling through space. The particles have enough of this kinetic thermal energy to overcome the attractions between them, allowing them to move around. Whereas particles in solids are going to vibrate in place, but they can't move relative to each other. So, imagine if we were all wearing Velcro suits, right? And we all, kind of crowded into just part of the classroom, and then we were trying to move past each other. It would be hard, right? Because we'd be sticking to each other. And that's what solids are like. They're stuck, and they just don't have enough energy to break loose. In order to break loose and get away from those attractive forces, you have to be moving faster or using a lot more force to pull away from the Velcro, right? These are ideas that we talked about in an earlier chapter, but they bear repeating. Gases have low density. They have an indefinite shape and an indefinite volume. They can change their shape and their volume. Liquids have a much higher density. They also have an indefinite shape, but they have a definite volume. The volume won't change when you pour it from one container to another, but the shape will change. And we are familiar with all three states of water, and so you can kind of use those to help you remember if you see a question like this on an exam. Solids are going to keep their shape and keep their volume. And this is because these have strong intermolecular forces. Liquids have moderate, and gases have very weak intermolecular forces. So liquids will assume the shape of their container. Gases are compressible, while liquids and solids are usually not compressible. And that's why hydraulic brake system works. It's got a brake fluid, a liquid in it, and you put pressure on one end of that tube of liquid, and it applies that pressure to the other end of the tube, because you can't compress a liquid. So here we've got a liquid in this cylinder thing here, and you can push down on that top as much as you want. You can't squeeze the molecules any closer together. If you have a gas in here, though, there's a lot of empty space. And so if you put pressure on this, you can cause those gas particles to become closer together. So gases are compressible. There are different types of solids. Crystalline solids are going to have particles that are arranged in a well-ordered manner, and that's usually three-dimensional arrays. So this might be a crystalline solid, and everything's all lined up and really neat and everything. Whereas amorphous means without shape, and these are just a bunch of atoms or molecules jumbled together and stuck as a solid. Okay, which state of matter is compressible? Gas. You can squeeze gas into a smaller container. Substances can change their state. You're familiar with this with water, right? If you take water in the solid state, how can you make it become a liquid? You heat it up, right? So you heat the solid, it will become a liquid. And then if you heat the liquid, it will turn into a gas. And then the opposite is true. You can take a gas and cool it to become a liquid, it condenses. And you can cool a liquid further and freeze it into a solid. Now, pressure can also have this effect between a liquid and a gas. If you put enough pressure on this gas, squeeze it close enough together, the particles get close enough that they start to stick to each other and it'll compress into a liquid. If we take this and reduce the pressure, we can cause it to spread out and it'll turn into a gas. So if you've ever used a gas grill to cook hamburgers, you might have used a gas cylinder like this. It's liquefied petroleum gas. It's mostly propane. So it's liquefied because it's under a great deal of pressure. This is a gas at room temperature, but it's a liquid in the cylinder because it's been put in there with so much pressure. Why would we want to do that? It takes up a lot less space as a liquid, right? So here we have it all as a liquid. It's really compressed together, and then we can let it out a little bit at a time, and we don't have to replace the gas cylinder so often. Some of this, there's always going to be a headspace above here, and so some of these molecules are going to get into the gas state, but there's only a little area for them, or volume for them to be in the gas state. Then if you open the valve, they will come out, and then you can light them and grill your hamburgers. So here is a molecular diagram showing a sample of liquid water. And there's our little red and white Mickey Mouse head molecules. Okay. Which of the diagrams below best depicts the vapor emitted from a pot of boiling water? Is the process of going from a liquid to a gas a physical change or a chemical change? It's a physical change. So what happens to the individual particles? Nothing. They stay the same. The only thing that's different is they're going to be more spread apart, right? So what's the correct answer here? A. We have the same water molecules. It's still water. They're just further apart from each other. Here, the water has been decomposed into oxygen gas and hydrogen gas, and here they're split into individual atoms. This would happen if you pass an electric current through the water. This, I'm not exactly sure how you would accomplish that. Any questions?